Even and odd properties of trig function. All right, so in pre-calc 1, you might have talked about even and odd functions, and the properties were this. It's kind of an obscure thing. With odd functions, and there's information about like being symmetric about the y-axis, the x-axis. We're not going to talk about the symmetry part of even and odd functions, just the algebra part of even and odd functions. A function was odd if you put a negative input on the inside and you could just like take the negative out and just find f of whatever the positive part of that number was and then make it negative, make the whole thing negative. That was an odd function. A even function is where it destroys a negative when it gets a negative number put in. So f of negative x is just equal to f of x. All 6 trigonometric functions are either even or odd. So we have the odd trigonometric functions are sine, tangent, and then their soulmates are as well, because soulmates are all the same. So cosecant and cotangent, those are all odd. And then the other two, cosine and his soulmate secant, those are both even. So if you put all of that together, you'll get that with sine, if there's a negative on the inside, you can just take it on the outside instead. Same with cosecant, tangent, cotangent. And with cosine and secant, the negative on the inside could just be destroyed. So just quickly, use the even and odd properties of trig functions to evaluate the following. All of these are negative angles, which is kind of annoying, right? Like negative 60 degrees. You have to figure out like where negative 60 degrees is, even though the unit circle doesn't have them listed here. But with even and odd properties, this becomes easy. So first of all, cosine of negative 60, if there's a negative on the inside, then we can just destroy it because the function is even. So this is really just cosine of 60 degrees. Cosine of 60 degrees. That's going to be the x value at the 60-degree mark. The x value at the 60-degree mark, which is 1/2. Now, if you had done negative 60 would take you to right here. And indeed, you'd get the same cosine back. Cosine of negative 60 would have still been 1/2. You get the same answer, just comes about in a different way. So cosecant of negative 225 degrees. Cosecant is soulmates with sine. Sine is odd. So that means the negative on the inside can be brought outside instead. So this is the same as negative cosecant of positive 225 degrees. So that'll be 1 over sine. This will be, well, the reciprocal of sine at 225 degrees. So sine at 225 degrees, sine of 225 degrees, that's the y value at 225 degrees, is negative, let's do a highlighter here, is negative root 2 over 2 is equal to negative root 2 over 2, which means cosecant of negative 2 of positive 225 degrees is the flipsy-flu of this. So that negative that's out front stays out front. Then I do the flipsy-flu, so this will be negative 2 over square root 2 because it's cosecant, not sine. And now we have 2 negatives, so that becomes a positive 2 over square root 2. If you had done negative 225 degrees, that would have taken you, negative 225 would have taken you to here. Your y value would have been root 2 over 2. So sine of negative 225 would have been root 2 over 2. You would have flipped it upside down and gotten the same answer we got over here, 2 over root 2. All right, next one, same idea. Tangent is also odd, so the negative can be taken out front. So this becomes negative tangent of positive 7 pi over 4. Positive 7 pi over 4. That, what color should I use here? Tangent of 7 pi over 4. I'm dividing the y value by the x value. So let's see, tangent of 7 pi over 4 is negative root 2 over 2 divided by root 2 over 2, which is negative 1. So we have this negative out front, and that stays there. Then tangent of 7 pi over 4 itself is negative 1. So we have negative negative 1, which is a positive 1, and that is the answer. Okay, and oh, to prove this here, negative 7 pi over 4, negative 7 pi over 4 would be right here, so it would be on this line here. And if you took tangent there, you would get tangent would be 1, which is the answer we got. All right, for the very last one, secant of negative 11 pi over 6. Secant is even, just like cosine, so that means that the negative just doesn't mean anything. We can do secant of 11 pi over 6. So 11 pi over 6. And secant is cosine, so that's the x value. That's too big of a marker. That's the x value. So we know cosine of 11 pi over 6 is square root 3 over 2, which means that secant of 11 pi over 6 is the flip-c flu. So that's going to be equal to 2 over root 3. And indeed, if you look, so negative 11 pi over 6, negative 11 pi over 6 would take you all the way to this spoke right here. You would be looking at the flip-c flu of the x value. The x value is square root 3 over 2. So indeed, they are the same. You get the same answer either way. All right, so those are the even and odd properties of sine and cosine and well, all of them. Those are the even and odd properties of the trig functions. Those are how those properties work. We can use these properties now in proving identities. So our next video, our very last, I thought this was our last video, but our very last video, because I separated these, we'll be using these even and odd properties to actually prove trig identities. I'll see you in that video. Bye.